Imagine walking into like a high-end live broadcast studio. Normally you'd see a small army of people.
Oh, yeah. Tons of people.
Right, like camera operators, focus pullers, lighting techs, all just scrambling around to get the shot. But today, we are looking at what happens when you condense that entire crew into a single robotic tower.
It really is wild to think about.
It is. So welcome to the deep dive into our source material for today. We are exploring the Bolin Technology R9-420F 4K camera. And, okay, let's unpack this, because this isn't just a camera.
No, not at all. It is way more than that.
It's like an automated bridge between the physical chaos of live broadcasting and the absolute precision of virtual reality. It's essentially a robotic, multitasking, one-person film crew, almost like it has, an octopus's ability to juggle tasks.
That is a great way to put it, actually. I mean, it fundamentally changes the logistics of live production. We are talking about a device engineered to handle complex real-time broadcast operations entirely on its own.
Right. And to understand how this machine actually pulls that off, we first have to move from its overarching purpose to its eyes and brain.
The sensor.
Exactly. We're looking at a 12.8-inch Sony Starvis eye sensor with 8.29 megapixels. But honestly, forget the raw numbers for a second.
Yeah, the specs only tell half the story.
Right, because what that actually means is its extreme low-light capability is just absurd. It goes down to 0.1 lux in black.
Which is, that is basically a pitch black room.
Right, a room where a standard lens just sees dark mud. But here's my question. The brain driving that sensor is an AI-powered facial analytics engine for auto exposure. How does that actually differ from, say, the smartphone in my pocket just trying to find a face?
Well, what's fascinating here is the continuous real-time math happening under the hood. Your smartphone applies general algorithms to relatively static scenes.
Okay, yeah. Like it's just guessing at the average light.
Exactly. But the Bolin's AI actively analyzes the complex lighting environments in real time. It separates the human subject from a really chaotic background and overrides standard exposure rules.
Wow. Okay.
Yeah, so it ensures the subject is perfectly exposed, and it does this continuously, without any manual human intervention.
That makes sense. But a sharp image is pretty useless if the camera can't dynamically follow the action.
Completely. The movement is everything.
Which brings us to its robotic tracking and virtual world integration. We are talking about serious PTZ's mechanics here.
Yeah, it has a 340-degree pan.
Right, a 340-degree pan, a 120-degree tilt, and a massive 20x optical zoom. And crucially, it integrates the Freed protocol.
Which is huge for virtual environments.
Yeah, so is the Freed protocol essentially a spatial GPS beacon? Like, does it just tell virtual environments exactly where the camera's looking?
That is a perfect analogy, but it is actually even more granular than a standard GPS beacon.
Wait, really? Like, how so?
Well, the Freed protocol actively translates those physical mechanics into raw axis tracking data. So it knows the exact degree of the pan motor or, the precise millimeter of the lens glass shifting.
Oh, wow. That is incredibly precise.
Yeah, and it feeds that continuous stream of data directly into third-party AR and VR software, which enables spectacular, completely automated AR and VR video production.
That is incredible. So we have captured both physical and virtual data, but now we must seamlessly deliver it to the world. And the connectivity on the back of this thing is just stacked.
Oh, it really is the connectivity hub.
Right. It has this true dual output feature for simultaneous HDMI 2.0 and 12 GSDI outputs in entirely different formats. Plus, optical SDI, IP streaming, and professional balanced XLR audio inputs with 48V phantom power.
That is a massive amount of I/O for one unit.
It is. But honestly, here is my pushback. So what does this all mean for you, the person actually trying to run a live event? Do we really need all these simultaneous outputs running at once, or is this just feature bloat?
Well, if we connect this to the bigger picture, you have to think about high-end broadcasts. They require zero latency, distinct feeds for different teams all at the exact same time.
Ah, okay. So like different feeds for streaming versus live screens.
Precisely. Your streaming team gets their compressed IP feed, the venue's live screens get an uncompressed signal, and your recording team gets another format entirely, all at once.
Man, so the barrier to entry for broadcast-grade quality is dropping incredibly fast.
It really is.
I mean, the line between massive multi-crew broadcast studios and automated single-camera setups is just rapidly disappearing.
It's completely disappearing. It lets one robotic unit do all the heavy lifting.
Which really leaves us with a pretty wild, provocative thought to chew on. If an AI camera can perfectly track, focus, expose, and feed spatial data into a virtual world entirely on its own, what happens to the traditional role of the human camera operator in the future of live events?